Hello viewers, I am Maitli. Today we are going to see 12 Cbse Maths Continuity and Differentiability exercise 5.1 question number 22. Let's see the question. Discuss the continuity of cosine, cosecant, secant and contingent. Now cosine is nothing but cos, this is cosecant, this is secant and this is cot. Now we are going to prove it separately. First let us take cosine. So let f of x is equal to cos x. Here in the place of x I am going to take it to be a. We know that left hand limit will be a minus h, right hand limit will be a plus h. If we are going to take it to be a, here h will be 0, only then we can write this to be x will be equal to a. If h is equal to 0, the same way x will be equal to a when h is equal to 0. So limit h is equal to 0, I need to substitute when it is a minus h or a plus h. So let me take the left hand limit. Limit extends to a negative f of x. Here instead of x extends to a, I am going to write limit h tends to 0 f of a minus h because it is a left hand limit. Here in the place of x we need to substitute a minus h because it is given at cos a. So limit h tends to 0 cos a minus h. It is in the formula of cos a minus b. So here it becomes limit h tends to 0 cos a cos b plus sin a sin b. Substitute the value of h as 0 in the place of wherever you see h. So cos a cos 0 plus sin a sin 0. We know the value of sin 0 is 0 and cos 0 is 1. So here it becomes cos a, here 1, so cos a into 1 is cos a plus sin a into 0, here sin 0 is 0, so everything will become 0. The final answer is cos a for LHL. Let me write for RHL. For RHL the same thing, limit extends to a positive f of x. We know that limit h tends to 0. I need to take a plus h, f of a plus h. Limit h tends to 0. Here we know it is cos x, so instead of cos x I can write it to be cos a plus h. So it is in cos a plus b formula. So cos a, limit h tends to 0 cos a cos b minus sin a sin b. Now substitute the value of 0 in the place of h, it becomes cos a cos 0 minus sin a sin 0. Sin 0 is 0, so everything will become 0. Here cos 0 is 1, so here it becomes cos a into 1 will become cos a. So here LHL is equal to RHL. Let me write it here. LHL is equal to RHL. Both are equal to cos a. Now if both are equal, we can say therefore it is continuous at x is equal to a. So we have proved with cos a is continuous, that is cos x is continuous. We'll move on to cosecant. For cosecant, let me take f of x to be cosecant x. Here cosecant x can also be written as 1 by sine. So I am going to take this to be f of x to be 1 by sine x because it will be easy for us to solve the formula. Here the same thing. I am going to take x to be a. Here it becomes a minus h. This side will become a plus h. This is your left hand limit and this will be your right hand limit. Now limit extends to a f of x. Your left hand limit extends to a sorry, h tends to 0. Let me take it to be h tends to 0, so that I can write it to be when h tends to 0 only, it will be a minus h on the left hand limit. So f of a minus h. Here limit h tends to 0, we know that it is f of x is equal to 1 by sine. In the place of x we need to substitute a minus h. Now in the denominator it is in the formula of 1 by sine a minus b. So we know the formula of sine a minus b. Substitute the formula, limit h tends to 0, 1 by sine a cos b minus cos a sin b. Now substitute the limit value, that is limit h tends to 0. So in the place of h substitute 0, it becomes sin a cos 0 minus cos a sin 0. Now we know that sin 0 is 0 and cos 0 is 1. So here it becomes 1 by sin a into 1 is sin a. Here totally it will become 0. So your final answer is 1 by sin a for left hand limit. Let me write the right hand limit. Your right hand limit is RHL is equal to limit h tends to a positive f of x. We know that for right hand limit we need to take a minus h when h tends to 0. So here it becomes limit h tends to 0 f of a plus h. Limit h tends to 0 f of x is 1 by sine x. Here we have a plus h. So in the place of x write a plus h. Limit h tends to 0. It is in the formula, in the denominator is in the formula of sine a plus b. That is sine a cos b plus cos a sin b. Now 1 by substitute the value h, it becomes sin a cos 0 plus cos a sin 0. Now sin a cos 0 is 1, so totally it will become 1 by sin a, because here it becomes 0. We know that LHL and RHL both are equal. So therefore LHL is equal to RHL. It is continuous at x is equal to a. That's all, we have proved that it is continuous at x is equal to a, that cosecant x is continuous. Now we'll move on to the next subdivision. What they have given is for secant. Let me take f of x is equal to secant x. Secant x can be written as 1 by cos x, because it is a reciprocal for cos. So I am taking secant x to be cos x. Same way x, I am taking x to be a. Here it is left hand limit, so it becomes a minus h. It is right hand limit, here it becomes a plus h. This is RHL and this is LHL. Now limit x tends to a f of x. In the place of h I need to substitute 0, only then I can take a minus h. So h tends to 0, it becomes f of a minus h for the left hand limit. Now limit h tends to 0, f of x can be written as f of x is 1 by cos, in the place of x a minus h. It is in the formula of cos a minus b. We know the formula of cos a minus b, that is cos a cos b plus sin a sin b. So limit h tends to 0, here cos a cos b plus sin a sin b. Now substitute the value of 0, it becomes 1 by cos a cos 0 plus sin a sin 0. Now this is equal to, here cos 0 is 1, so 1 by cos a. Here everything will become 0. So final answer is 1 by cos a for the left hand limit. Let us try it for right hand limit. Here right hand limit, the same pattern we are going to do. Limit x tends to a, f of x, a positive. Here limit h tends to 0, f of a plus h. On the right hand side we have limit a plus h, so we are going to take a plus h. Now limit h tends to 0, 1 by cos a plus h. Here we have cos a plus b formula. We know the formula, just substitute the formula. Limit h tends to 0, 1 by cos a cos b minus sin a sin b. Substitute the value of h is equal to 0. It becomes 1 by cos a cos 0 minus sin a sin 0. We know that sin 0 is 1, sin 0 is 0, so everything will become 0. It becomes 1 by cos a. The same thing what we got for LHL. So here LHL and RHL both are equal, so we can write this to be LHL is equal to RHL. Therefore it is continuous at x is equal to a. Now we'll move on to the next subdivision, that is cot. Taking f of x as cot x. Let me take it to be 1 by tan x because it is easy. We have a formula for tan, and for us it will be easy for us to solve with the cot formula. Now x is equal to a, here it becomes a minus h, a plus h when x tends to, h tends to 0. This is your left hand limit, right hand limit. The same pattern we need to continue here. We are going to take left hand limit. Here left hand limit is limit x tends to a f of x. Here limit h tends to 0. I can take this to be a minus h in case of the left hand side. Here limit h tends to 0. This can be written as 1 by tan a minus h. Here we have a formula for tan a minus b. Tan a minus b is nothing but tan a minus tan b by 1 plus tan a tan b. Now substitute the value of h tends to 0. In the place of h, substitute 0. It becomes 1 by tan a minus tan 0 by 1 plus tan a tan 0. Now we know that tan 0 equal to 0. So here it becomes 0 in the denominator. Here it becomes 0. So it is tan a, 1 by tan a by 1. So 1 by tan a by 1 is nothing but 1 by tan a. So this is your LHL. LHL we got it as 1 by tan a. Now we'll move on to the next RHL. RHL is limit x tends to a f of x, a positive. Here limit h tends to 0 f of a plus h. On the right hand side we have a limit as when h tends to 0 it is a plus h. Now limit h tends to 0, f of a plus h, I can write it to be 1 by tan a plus h. Now limit h tends to 0. We know the formula for tan a plus b, that is tan a plus tan b by 1 plus tan a tan b. Now substitute the value, h is equal to 0. Here it becomes 1 by tan a. Here it becomes 0 plus tan 0 will become 0 by 1. I am skipping a step, that is by 1 plus, here tan a plus tan into tan 0, the total will become tan 0, sorry, by 1. Here it is 1 by tan a by denominator 1, and finally we can write this to be 1 by tan a because here it is 0. So 0 into any number will be 0. So 1 plus 0 will be 1. Now if you see your LHL and RHL both are same. So it is 1 by tan a. Here also it is 1 by tan a. So we can write it to be LHL is equal to your right hand limit. So therefore it is continuous at x is equal to a. That's all with the sum. Thank you.